Boys and girls, dear viewers, I am Bins, and welcome to the 16th video in the Shapez
BEASTMAM series.
With regards to the decoder, we've talked about
Number 1.
how the clock operates,
Number 2.
how we use it to cycle between a jillion shapes in rapid succession,
Number 3.
how we combine those outputs to create chunky combo floats,
Number 4.
how we strip those pieces out of the main signal in order to determine the group of quadrants that the clocks haven't selected, and then finally,
Number 5.
how we throw in a fifth layer for good measure. With that, we have all the ingredients we need in order to be able to ask that one crucial question: if we put all of it together, do we obtain the final shape or not? Within Chapter 4, about the decoder, we're going to open up a new subchapter, Subchapter D, and that one will be all about the validation module. The validation module, or validator for short, is the module that will take all the inputs we've been establishing, throw them into one big melting pot, and then see if there's a match with our target shape or not. And as such, it's a pretty big deal for the success of this machine. The topic of the validator will be covered in 2 parts, and today is the first one. Now, if we look at the validator, we can see that it consists of 1, 2, 3, 4, 5, 6, 7, 8. And that's not all, because this one also counts. It consists of 9 parts. And each of these parts is responsible for one particular scenario that we need to take into consideration. And so, the question I'd like to focus on for today is, why 9? Now, if you've seen my BEASTMAM or BEASTMAM series, which were about building a TMAM in the vanilla Shapez game, you may recall that in vanilla, even if you have all the correct components, sometimes it is still relevant how you bring those pieces together. More specifically, in which order you need to stack them. And well, for once, that particular aspect is actually easier in the Shapez Industries TMAM, at least with this algorithm I'm using in the BEASTMAM. The order in which we need to stack the various components we've been building up to here is always going to be the same one. And that has to do with the nature of the pieces that we have been building and gathering. All right, let's start with the fifth layer. If we've got a fifth layer, it will always have to be stacked on top, per definition, right? Now, if we have a remainder on layer 4, then that will always have to go directly below that. Okay, if we get a remainder on layer 4, then that will always go directly below layer 5. That's a given. Now, if we have a floating piece or combo float that has base layer 3, then per definition, it will also have at least one quadrant on layer 4. It must have, because otherwise it wouldn't be a floating piece. All right, and since we know that that's the case, we also know, firstly, that this floating piece will touch the ceiling that is the fifth layer, and secondly, this piece can never, ever have any quadrants that overlap with the remainder of layer 4, because that is what the remainder is, after all, the group of quadrants that is not in any of the floating pieces. If we were to get any overlap here, that would mean we've made a mistake somewhere in the setup, because in theory, this can never happen. And therefore, a floating piece with base layer 3 can always be stacked directly below the remainder of layer 4. And we can now continue with this logic all the way down the shape. If we have a remainder on layer 3, then it can never overlap with a combo float of base layer 3. And so, if we do have a remainder on layer 3, we can stack it directly below what we already have. Now, let's say we have a floating piece with base layer 2. Again, it cannot contain any quadrants that are anywhere in the pieces we've already got. Any layer 3 quadrants that are in this float can't be in the remainder of layer 3. And even if this is a tri-float, well, then our subtraction module would have detected that and chucked out the relevant quadrants of the remainder of layer 4. Alright? So that gets stacked below. That gets stacked on top of the remainder of layer 2, which gets stacked on top of any base layer 1 combo float, which finally gets stacked on top of the remainder of layer 1. Always. This will always be the stacking order. It can't be any other way. Now, at this point, I do want to point out that in practice, we will never actually get all of these pieces at once for any one given shape. But regardless of which ones we do and which ones we don't, this will always be the stacking order, and that makes life quite easy for once. Now, let's move over to the less easy stuff, because while we are at the point where we are almost ready to compare our output to the final shape to see if there's a match, the entire decoder hasn't dealt with one of the hardest things yet, the bane of any Shapez Industries player's existence: smelting. We've completely disregarded smelting so far, haven't we? So how on earth do we figure out smelting? After all, we might need to stack everything first and then smelt it, or we might need to stack some of these pieces, smelt them, and then stack it to the rest, or maybe one, or maybe more than one of any of these pieces needs to get smelted before we stack anything. Alright? So does that mean we need to take into account a smelt option before and after every step of our stacking process? Well, no. Not if we stop to think about what we're doing and what the actual possibilities are. The first question I have for you is, do we ever need to smelt any of the remainders? Do you know the answer? Well, the answer is no, we don't. Look at this shape, for example, right? If we let the decoder loose on it, it will find all kinds of floating pieces, including eventually the correct one, which is the green-blue duo float on the right. And if that, in our decoder, in the machine, turns out to be the currently selected piece, well, then, because of the way the subtraction module works that we spoke about in previous videos, it will strip that floating piece from the input and leave the rest. That's what the remainder is, right? And what that means in terms of smelting is that when the signal is smelted, when it goes into the subtraction module, well, then it will still be smelted when it comes out, right? The subtraction module just strips out quadrants. It doesn't otherwise break any smelted shapes or anything, right? So that means that for our validation module, we don't actually need to include optional smelt points for any of the wires that contain remainders. If those pieces are smelted, then the signals will be smelted when they go into the validator, and we don't need to worry about that anymore. And that also means we can considerably downsize the number of smelt options. In fact, we're left with only 4 points where it may make sense to smelt the shape. Firstly, the combined float piece with base layer 1 could either be smelted before it gets stacked or not. The combined float piece with base layer 2 could be smelted before it gets stacked or not. The combined float piece with base layer 3 may need to be smelted before it gets stacked, right? And or the target shape as a whole may need to be smelted after all of the stacking has been done. Those are our 4 checkpoints. Look at it, because firstly, we've ruled out that the remainder lanes require optional smelting before they're stacked. Secondly, it's never gonna matter one bit whether we smelt the 5th layer or not. And thirdly, the stacking order is strict and invariable. Those 4 checkpoints are the only ones where smelting could ever make sense. So this dramatically reduces the amount of variables we need to work with. But there's still a catch. So we've got 4 locations where smelting may need to occur. And for any of those locations, we've got 2 options. Either smelting is required at that point, or it isn't, right? And we do need to take into consideration that we might need to smelt at any of these points, including any combination of them. So if we pull up a sheet to look at all of the possibilities, you will see that this actually becomes a 4-bit binary count, right? In this sheet, let's say this is the final smelter. This is a combo float 1 prior to stacking, combo float 2, and combo floats on base layer 3. So the first option is that we don't have to smelt anywhere. The second option is that we only smelt for combo float 3 prior to stacking. Third option is that we only use combo float 2. The fourth option is both of them, etc. Let's quickly complete this table. There we go. And so you can see that we have 16 possible smelt scenarios in total, right? Which isn't the end of the world, actually. And there is actually more good news. If we take a closer look at the locations of our smelt points, well, then consider this. If the solution requires us to smelt the shape after it's been stacked, then it doesn't matter whether we smelt any of the combo floats or not, right? After all, you cannot double smelt a shape or anything. So it wouldn't make sense to smelt any of the combo floats prior to stacking if we're gonna smelt the stacked shape afterwards anyway, right? And what that means for our tally is actually that we can get rid of 7 of our lines right here, like so. If we're gonna smelt the shape after stacking anyway, then we can completely disregard the other 3 checkpoints. And that is how we end up with a total of 9 scenarios. 9 ways in which we may need to weave smelting into our stacking so that hopefully one of them will find a match with the target shape. So, as to the title of the video, why 9? Well, now you know. In the next episode, we are going to take a look at 2 additional parameters that come with the validator module. But for today, this is what I wanted to talk about. Why do we have these 9 scenarios? Where do they come from? And then in the next episode, we will take a closer look at what they are, right? Now, as always, I want to thank you for watching. I hope it was interesting. I hope you had fun. Subscribe if you don't want to miss out on future episodes in this series. Leave a like, leave a comment, all that good stuff. And with that said, I am out for today. Take care, have a great day, and see you soon. Ciao.